good to post this on Google Classroom.
That's fine. Just put the hard copies in there. Yep. Piper. Lucas. I guess our speakers aren't going to work today. All right, before we start our quiz this morning, I'll give you a chance to turn in hard copies of those assignments if you did not get a chance to turn them into Google Classroom. So as always, you can still turn these in later for late credit, but your last chance for full credit is before we start the quiz. So that would be 23, which was the 4.5 notes, 24, where you matched equations to graphs, 26, which was the book assignment, and 28, which was the 2 practice quizzes. So if you, for whatever reason, didn't get that in Google Classroom, make sure your name is on each of those and come turn them into the basket before we get started. Our quiz this morning is no calculator, and I need your phones and smartwatches put up on the side of the room. So once you've done all that and your desk looks cleared off, I'll get you the quiz to let you start. Too terribly long, and we did discuss some ways to check some of your graph answers at least last class, so you remember that. And you have time to do that. It's obviously highly recommended. Did I skip anybody that I did not come back to yet? Okay, make sure your name is on it, and you should number it as number 29.
Mia didn't make it.
Bless you. you. Get back over there, please. And take your name off the board. if you're still working, that is fine. But for the rest of us, we need to move on here so that you can get the next piece that you need to get. So there was 3 handouts that you guys picked up on the way in. Those are the ones we're going to be looking at, 30, 31, 32. So this would be our last section in this unit. And this certainly can be the easiest section because we just need you to know some real basics from this. So in fact, what we expect you guys to be able to do in section 4.6, you could actually just memorize it all and not even know any trig at all and still be able to make 100 on that part of the quiz. So we've got the 4.4 stuff on our second test coming up. That will be, for some people that's easier than others. Kind of depends on how you did on 4.1 through 4.3. You should have a good gauge of how you feel about 4.5. And then the last of it is 4.6. So even though these 3 handouts look like a lot, 2 of them, not the notes page, but the other 2 of them are the practice. So we don't do a book assignment in this section. These notes and the 2 practice worksheets are the only things from 4.6. So in 4.6, we've already talked about what sine and cosine look like. So you still need to know those 2. Now in 4.6, we don't do any transformations at all. So no amplitude changes, no phase shift changes, none of that stuff, not in 4.6. Now again, if you forget which one is sine and which one is cosine, which I think is kind of hard to do at this point in the year, remember you could always plug in some unit circle values. Sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1. We did that in the section 4.5 notes to talk about where some of those points came from and then just knowing the general shape and connecting it. Same thing with cosine. If you ever forget what cosine looks like, you can just throw in some unit circle points, like the cosine of 0 is supposed to be 1. So 0, 1 has to be a point. You could do pi over 2 or pi or 3 pi over 2. And you can get a few points, and that can help push you and remind you of what those graphs looks like. Even though I think that's probably not necessary for sine and cosine, that same strategy is going to help us out with the other 4 trig graphs. So the big part, 4.6 really boils down to 2 things. We want you to know what the other 4 trig graphs look like, so secant, cosecant, cotangent, and tangent. And we can discover what those look like doing the same trick here, doing unit circle points. And we're going to ask you some characteristics about the graphs. So we're going to ask you where there's any asymptotes. So if you don't remember what an asymptote looks like, it kind of looks like this. It's a vertical spike in the graph. And sine and cosine don't have those. We are going to ask you about the domain for each of these questions. Now, if you don't remember what domain means from algebra class or range or even odd, any of this stuff, you should probably write it out to the side once, because we're going to need to answer the same thing about the other ones. But domain is asking what x values does it hit, and it goes forever to the left and forever to the right. So forever to the left and forever to the right. Both of these hit every x value possible. Whereas range is asking what y values does your graph hit. So it goes down as low as -1 and up as much as +1. Now for domain and range, these parentheses and these brackets are very important. Putting in a bracket where there's a parentheses or parentheses where there's a bracket can make it incorrect. Technically you can't ever reach infinity or negative infinity, so those are always parentheses. On these graphs, you can actually reach a y value of 1 and reach a y value of -1. So since we can reach those values, we need to include them, which is parentheses. Okay, the even and odd. If you still have that memorized, that cosine and his reciprocal are the only two even functions, and the other four are odd. You can answer those that way. Or another method to do that is look at the type of symmetry that the graph has. If the graph has symmetry with respect to the y-axis, that's a characteristic of even functions. So if I take this graph and flip it over the y-axis, it lands on the other side perfectly. So that's another way to know that it's an even function. Whereas odd functions are symmetric to the origin, which means that it has 180-degree rotation. If you take the sine graph, take a mental snapshot of it, turn it exactly upside down, it still looks the same. That is a characteristic of an odd function. So to me, these two questions are really kind of going together. But. Okay, period represents how much space you need to see the full graph. And so with the parent functions, those are both 2 pi. And then finally, the last characteristic that we will quiz you on is whether this is continuous or discontinuous. So continuous means you have a nice smooth graph, you don't have any holes in your graph, you don't have any asymptotes. So both of these two are continuous. There's no sudden breaks in the graph. So moving forward, we need to talk about what the other 4 graphs look like and then be able to answer these same exact things about it. But if you can get the graphs down correct, then, and you know what these are asking for, then that's usually pretty straightforward. Okay, the next two we're going to look at are tangent and cotangent. So I guess like maybe on the ACT or something, you could graph these in your calculator real quick. We want to see that you can do this without a calculator. So worst case is just like I did with sine and cosine in section 4.5. I'm going to just plug in a couple unit circle values so that you can see how close you can get to this by just plugging those in. If I do 0 and I think of tangent as sine over cosine, the sine at 0 is 0, the cosine at 0 was 1, but 0 divided by 1 is 0. So simply thinking about the tangent of 0 equals 0 means that you know it goes through 0, 0. Okay, pi over 4 is a pretty easy one because pi over 4, sine and cosine are both square root of 2 over 2, and anything divided by itself is 1. So at pi over 4, you get 1. And you really probably only need to know one more after I show you what the shape of this graph looks like. If we did negative pi over 4, sine and cosine are again square root of 2 over 2, both of them, but sine is negative. And something divided by itself would be 1, but if one of them is positive and one of them is negative, it's going to be negative 1. Of course, you can do more points. You can do as many points until you feel comfortable with what you think the tangent graph looks like. But realistically, a couple points like this and just knowing the general shape of the graph is enough. This is what one cycle of tangent looks like. So copy that over again and again and again. Now, the reason why I think this is so important here is you're going to see that the cotangent graph looks very similar to the tangent graph. Some students just try to memorize which one's tangent and cotangent, and it works out for them. And some students get these two mixed up, and they don't do well on their 4-6 quiz. And it honestly can be the easiest one of the entire semester. So, I don't know. This isn't a mathematical description, but I think of this as snaking up for the tangent graph. Cotangent is going to be similar, except it's going to snake down, and it's going to hit some different points. But in general, it's kind of the same shape as this. So we don't have to assume anything about it. We can think of this as sine under cosine. We can do a couple unit circle points. At 0, cosine is 1, but sine is 0. We can't divide by 0. And when you try to divide by 0, that's when you get a asymptote. In fact, over here I should have done the same thing. In math, when we have vertical asymptotes, you should graph those as dashed lines. That's the asymptotes it's going to be referring to down here. Okay, I could try to plug in something different, like, I don't know, pi over 2. Cosine at pi over 2 is 0. The sine at pi over 2 is 1. 0 divided by 1 is 0. So at pi over 2, we get 0. Pi over 4 is a good one because sine and cosine are both square root of 2 over 2, and anything divided by itself becomes 1. And this is plenty of points for me, but you would maybe want to also do like 3 pi over 4, and you would get -1. Sine is square root of 2 over 2. Cosine is negative square root of 2 over 2. Anything divided by itself is 1, but one's positive, one's negative. And then, again, you still kind of need to know the general shape, but that is what one cycle of cotangent looks like. Notice it's not in the exact same spots as tangent, but it's got a similar shape. Whereas I would describe this one as snaking up, this one is snaking down. Okay, but if that's one cycle, now that we were careful with the first cycle, we can copy and paste that and complete our graph. And we really should put dashed lines for our asymptotes. So once again, we will ask you to graph tangent and cotangent on your 4-6 quiz, so probably also your second test. But no transformations. You don't have to deal with amplitude with tangent and cotangent, no phase shifts, no vertical shifts, just can you graph the tangent and cotangent graphs from scratch. So know what the general shape looks like, know that they kind of look alike, and then plug in a couple unit circle points so that you're sure which one is which. Okay, and then, assuming we have our graph down, once you're good with that, then we should be able to answer these things about the graphs. So, let's just do both at the same time. So asymptotes, these actually do have asymptotes. You can't begin to list them all out because it has an infinite amount of them. There's one here, but if you keep going, there would continue to be more to the right and more to the left. So we have to come up with a formula that shows all of those. So there's an asymptote when x equals the vertical line. The way we do this is we're just going to name the first one, which is like pi over 2, or over here, the first one is 0. And then we're going to say there's another one if you add this distance. If you add pi, you get another one. But you could also subtract, pi, not 2 pi. This distance is pi. You could also add 2 pi, or 3 pi, or 20 pi, or 100 pi. Or you could subtract a pi, or subtract 2 pi, or subtract 20 pi. So we need to add multiples. So we do n, where n is an integer. And this little mouse symbol just means it's an element of, it's just a fancy way to say it's an integer. So as long as n is 1, 2, 3, 4, 5, 0, -1, -2, -3, -4, -5, something like that, this describes those. Now in this one, of course, adding 0 doesn't really do anything, so we usually write it like that instead. So the first one's at pi over 2 for tangent, the first one's 0 for cotangent, and then all the others are integer multiples of pi away. Okay, domain is asking almost the same thing, because domain's asking what x values can you plug in. And you can plug in most of this stuff, you just can't plug in the x values that give you asymptotes. So x can be anything as long as x is not at an asymptote. Otherwise, as long as you're plugging in an x value that's not an asymptote, it would be part of the domain. Now, very similar answers, but saying completely opposite things. Asymptote is asking where it is when x equals these values or x equals those values. Domain's asking what values can you plug in, and I can plug anything except those values. So x cannot equal those values. But range, the rest of this is a lot easier. Range is asking what y value says it hit, and this one goes forever down and forever up. So it is this one. Again, you don't really need to memorize that if you know what range is asking for and you can do the graphs. I memorized that both of these are odd functions, which means they both have symmetry to the origin. But if you know what it means to have symmetry with respect to the origin, you can turn your paper upside down and it still looks the same. You could do that for both of these, and you can see that both of these have 180-degree rotation symmetry, which we call symmetry with respect to the origin, which is a characteristic of odd functions. So again, to me, these go together. Okay, we're used to the parent function's period being pi, but that's not the case for these. If we start measuring from here to here to see one full cycle, that distance is only pi. From here to here to see one full cycle, that distance is only pi. So the period of these is pi. Can get that out of the graph. And then these graphs have all of the asymptotes everywhere, so that is referred to as discontinuous. To be continuous, you should have no holes, no asymptotes. Okay, before we look at the last two, is there any quick questions on how I graphed tangent or cotangent, or how I knew what these were asking for, since these are the same questions for all graphs?
What exactly does domain mean?
Domain is when you're describing the x values that you can plug into the function. So like the function, just a quick example, the function 1 over x, you can plug in any x value you want to as long as x is not 0. So that domain would be everything except x can't be 0 because it's division by 0. Okay, and so one more time, secant and cosecant, these two also look alike. So once I show you what the graphs look like, you just need to remember that these two are both similar. But like tangent and cotangent, they're not in the exact same place. They're not the exact same graph. So to differentiate those so that you're not just trying to memorize it and you're only going to remember it for a week or two anyway, let's plug in a couple unit circle points. I'm going to think of secant as 1 over cosine and cosecant as 1 over sine to make that a little bit easier. But if I try to plug in 0, I would get 1 over 1 because the cosine at 0 was 1. So that's right there. And honestly, that's enough information. Once I show you what the graph looks like, that's all that you would have to do here. But you could also try like pi, I guess. You get 1 over the cosine of pi, which is negative 1. To be honest, there's not a lot of other good points. You can plug in other unit circle points. The problem is you're going to get answers like the square root of 2 and things that you may not know the decimal for. So at this point, I would say you really need to know what the shape of the graph is. And this one has alternating parabolas that open up. If this point's above the x-axis, it opens up, and then that alternates with the parabola that opens down. That is what one cycle of secant looks like. And then it alternates. Opens up, opens down, so the next one would start to open up. The one before it would open down, and the one before it would open up. So 1 or 2 unit circle points to make sure you're starting it in the right location. But then just know the general shape of the graph. Cosecant is going to look almost the same. It's going to alternate parabolas opening up with parabolas opening down, but we don't need to guess and hope that we just have it memorized. Just plug in an easy unit circle point like 0. We should put our asymptotes over here as dash lines. You try plugging in 0 in the cosecant, you get 1 over 0, which is undefined. And when you try to divide by 0, that's what creates vertical asymptotes. So that doesn't help too much. We could try pi over 2. Pi over 2 is 1. And for me, that's enough, because I know it looks like this one. And now that I know this point's above the x-axis, this must be a parabola opening up, followed by a parabola opening down. Before the opening up must have been an opening down. Before the opening down must have been an opening up. So I really just needed this point to know that it was opening up here, and that is plenty. Okay, and it also has some asymptotes. Okay, like how we had to do the asymptotes with tangent and cotangent, we need to do the same thing with secant and cosecant. This has an infinite number of asymptotes. So what we need to do is say there's an asymptote at pi over 2. That's where the first one is. Plus, if I added pi, added 2 pi, subtracted 2 pi, subtracted 3 pi. So plus any integer multiples of pi. And we're going to use the letter n for integer again. Whereas the cosecant graph, his first asymptote is at 0, and then he's got another one pi units away, and 2 pi units away, and 3 pi units away, also negative 1 pi units away, negative 2 pi units away, so also integer multiples of pi there. And adding 0 doesn't really do anything, so we don't usually list that. Domain's asking the exact opposite. Domain's asking what x values can you plug in, and you can plug in anything you want to as long as it's not division by 0, which creates an asymptote. So the domain is everything that is not an asymptote. So same answer, but does not equal. Or same writing for your answer, saying the exact opposite thing. Okay, range is asking us to describe the y values. So it looks like it goes down as far as negative infinity, goes up to negative 1. It skips some y values, and then it hits 1 to infinity. So we have to write that like such. Negative infinity to negative 1, and then 1 to infinity. You don't have to use this U symbol, but that's just a math symbol for union, which is like a math way to say and. It hits all of these y values, and then jumps and hits all of these y values. It actually hits 1, so that has to be a bracket. It actually hits negative 1, so that has to be a bracket. It never can reach negative infinity or positive infinity. Those are always parentheses. If you look at this graph, it does the same thing. Starts off at the bottom, it goes up till you get to y values of negative 1, then it skips some, and then it hits all the y values from 1 to infinity. Okay, if you don't remember which ones are even and odd, I'm going to work this one backwards from how I did the first ones. Look at the type of symmetry. This is symmetric to the y-axis, which is a characteristic of even functions. This one is symmetric to the origin, because if you turn this graph upside down, it would still look the same. And functions that have symmetry with respect to the origin is a characteristic of the odd functions. So really you only need to know whether they're even or odd to know the symmetry, or you could look at the symmetry to know if they're even or odd. Okay, the continuous versus discontinuous. These are obviously discontinuous. It's got asymptotes all over the place, lots of breaks in the graph. The continuous versus discontinuous is not too important for pre-calculus, but continuous and continuity is a very big deal in calculus. And then period. If we know what the graphs look like, then we can go up here and measure. The period of this is not pi. If you only look at pi space, you either see a parabola up or a parabola down. To see the full pattern, open up, open down, you have to look at 2 pi of space. So the period is 2 pi. Same with cosecant. If you only looked at pi horizontal space, you would only see half of the pattern. To see a full cycle, parabola up and a parabola down, you have to look at 2 pi of horizontal space. So the part that I was saying that realistically you could still get 100 on this quiz and not know any trig is because we don't ask any variations of these questions. It's very transparent. We will ask you to graph for us tangent and cotangent, secant and cosecant. Those will be on the quiz. And then we're going to ask you some of these other things as matching. So you don't have to like try to memorize how to write it out. You just need to understand how it's written. So your other two handouts, 31 and 32, this is kind of the practice that goes along with that. So 31 gives you 4 graphs so that you can practice graphing tangent, cotangent, secant, and cosecant. So you should do that, then compare them to your notes to see if you did it correctly or not. And then number 32 is the big chart where you can draw a quick little sketch of them on one column and then answer the questions like domain, range, symmetry, even, odd, all the stuff that we talked about on your notes. But you should try it on the chart, then check with your notes, and then that should help highlight what it is that you need to study. So even though this is a very small amount of information, we will not be quizzing on this in next class. I'll give you about half of next class to ask questions from 31 or 32 after you finish those up, and we'll do part of our test review next class as well. So we're going to do part of the test review next class and part of the test review the class after. But there's no quiz next time.
Are we going to have a 4.6 quiz, or are we just going to straight through this?
There will be a 4.6 quiz, yes. And again, make sure you put in a best effort that you can on those worksheets, the 31 and 32, because that's the only practice you have in 4.6. No book work, no additional worksheets, no changes, no amplitude, phase shift changes. You saw the whole 4.6 that we expect you to know.